these sum and difference formulas. If you look on your sheet, on the side that doesn't say Augustana, it's on the other side. Well, they both say Augustana. But anyway, if you look at the top middle of one of them, it says angle sum and difference relations. And you will see a list of these. The difference in the way that it's written versus pre-calc book to the sheet is that the sheet used some shorthand. That's it. They did plus minus, but you have to be careful here. When you're working with the plus minus on these, I want you guys to take a look at the sign of u minus v. I'm sorry, the cosine of when you go u plus v. What happens to the sign on the inside? See how the cosine signs are opposite of the parentheses?
Yeah, what are you talking about?
The sine ones aren't.
Should we be looking at the board or on the sheet?
Yes.
What?
Let me explain it.
Yeah.
It's 72. It's never this one in here.
That's hot.
That's hot.
So on this sheet, when I'm looking at the sine formulas, it says sine of x plus or minus y, and then it equals sine x cosine x plus or minus cosine x sine y. It should be a y here.
Wait.
The top.
Can you fix your O?
See how both of those say plus minus, plus minus?
Yeah.
That means the top layer, the addition, if you have addition to start with, you use addition on the other side. Subtraction goes with subtraction. Whereas when it's written with the cosine on here, the cosine of plus x plus minus y, you get cosine x cosine y minus plus sine x sine y. That means when it's a plus xy in here, it's a minus over here. That's what I wanted to show you the differences in how this is written. They wrote them with all these plus minuses, obviously to save space. Okay? That's why it's written that way. That way you didn't have to write out all of this. Same thing goes for with the tangent stuff. On this form here, it talks about the tangent being plus minus. Well, if you follow through how it's written, the top one is for plus, the bottom one is the minus. So here, it'd be plus, plus. If it's minus, it's minus. If it's plus, it's minus. And if it's minus, it's plus. Does that make sense? The reason why they wrote it like that on this sheet is to save space. Okay, that's all it is. Okay, that's all it is. Goes the same thing when they wrote out the tangent one. If it starts out with the tangent of x plus minus y is tangent x plus minus tangent y over 1 minus plus tangent x tangent y. So again, if this problem starts out with a tangent plus in between, it would go plus in the numerator and negative in the denominator. That's what I'm just trying to show you guys why that's how they did it on here, just to show that it saves space. That's it. Does that make sense? All the top signs go together, all the bottom signs go together. That's all it means. So what do you do with sum and difference formulas? Well, you do something like this. Find the exact value of cosine of 75. You are basically going to be able to figure out sine, cosine, tangent values of angles that are made up of other angles you know. What's that?
Can you go back to the
program.
Okay. What are two nice, easy, normal angles that 75 is made up of? 45 and 30. So this means I can write this as the cosine of 45 plus 30. And I can simplify it and solve, bless you, using this formula sheet. Okay?
Well, how do you notice where they're looking?
Well, you're looking at the number they're given to you, and you want to break it into a number you know. One of the angles we know. 0, 30, 45, 60, 90, one of those. Out of your special direct triangles.
Okay.
That's what you're looking at. So this means that the 45 is playing the role of U, and 35 is playing the role of V. So as you substitute in. So, like I said, I'm not taking this from you because Lord knows I can't memorize this to save my life, so why should you? Can you simply follow direction? Cosine. Well, cosine of x, cosine of y. So pre-calc books use x's and y, or excuse me, uses the u and v. This sheet's using x and y. Does it matter?
No.
It's first term, second term, ladies and gentlemen. First term, second term. So cosine 45 times the cosine of 30. Now this one says it's cosine, so the next bit, is it going to be add or subtract the next part? Subtract. Sine of 45, sine of 30.
Why do you do sine?
Because that's the formula.
Oh, duh. Can you just plug it into your calculator?
No.
Why'd you put 3?
What?
What's the Because it's supposed to be a 30. What's the cosine of 45? Root 2 over 2. What's the cosine of 30?
Root 3 over 2.
We're just using your specials, 30,
Thanks.
60, 1 root 2. So you have root 3 over 2. What's the sine of 45? Root 2 over 2. And what's the sine of 30? 1/2. Okay. When you have fractions and you're multiplying, remember, you just multiply straight across. What's root 3 times root 2? 6. What's 2 times 2? Do we have a common denominator, ladies and gentlemen?
Yes, yes.
So my final answer is
Root 4.
root 6 minus root 2 over 4. I can't combine those because they're not the same value underneath the radical. That's it. That's all you do.
Like you don't need to put it in your calculator.
Nope. That's the exact, because it's the same, find the exact value. Found the exact value. That's it. Now, could you put it in your calculator to see if you're right? If you came out to the right answer? Absolutely. Throw your calculator in degree mode and type in cosine 75. You should get the decimal equivalent of that. And you can type that in your calculator with fraction bar and do the same thing. All right? That's how you find exact values. Let's try another one. Sine of pi over 12. Hi.
That's what you're like, taking your time with that. That's good for
I'm glad you're, wishing upon my death. Thanks, Maddie.
Oh, grab one.
Sine of pi over 12. Well, pi over 12, we got to figure out how is that made up of two other angles.
Pi over 6 and pi over 2? Nope.
Good job.
Well, you can't do pi over 2.
Well, think about it. How are you going to get common denominators? Common denominators, you'd have to multiply them together, right?
Yeah.
So you're right, you have a 2 and a 6, but that's not going to work. Pi over 3, pi over 4, very good. This is the same thing as saying sine pi over 3, pi over 4. Does it matter which one I put first?
None.
And now I follow the formula through using the sign.
When, do you ever use like subtraction?
There's some in different, I mean, yeah, if it's, I mean, you could. It just depends on the problem. I mean, let's see. I think I had an example of that in here. Like in your book, like question number 10, it's using, it says find the difference for 225 by using 300 degrees and 45 degrees. So you just do that. So yeah, you can use the differences as well. I mean, with 75 degrees, you could have done 90 minus 15, but you don't know anything about 15. So I follow my formula here. So this says sine pi over 3, cosine pi over 4, plus
I
cosine.
thought it would be minus.
I'm doing the sine one. Sine has positive up on top, positive again. Yeah. Is everybody?
Yeah, that's what I was.
Oh, it is the difference one. I'm an idiot. Sydney was right.
Yeah, it was.
Pi over 3 minus pi over 4. Then you get 4 pi over 3 minus 3 pi over 4. You get 4 pi over 12 minus 3 pi over 12. You get pi over 12. I know it was a 3. Chaos is 3s and 4s. I just automatically just wrote plus there. So now we have sine, still sine pi over 3, cosine pi over 4. And then now I'm going to do subtraction of, following this here, it's cosine pi over 3, sine pi over 4. Let's see, pi over 3 is which angle? 60. Pi over 4 is 45. So remember, if you want, just do a little sketch of your 30, 60s and your 45s. To be able to work it out a little bit quicker. Sine of pi over 3, root 3 over 2. And then I have root 2 over 2. Cosine would be 1/2, and a root 2 over 2. Mobile hold your mind up. Well, see what I think. So we just did what, 75? And then pi over 12. Shouldn't they have the same value for, as one has a cosine as the other one has a sine?
Yeah.
Because if you think about the patterns of what we had, 75 and 15 are complements to one another. Same deal with your 30 and your 60. Your cosine and your sine values switched. Ooh, look at that. It did the same thing with the 15 and the 75. Nah. And the reason is because it's still, your adjacents just went vertical as opposed to opposites. That's all. It works out that way. Kind of cool. But then again, I'm easily impressed and you really don't care, so that's okay. Evaluate a trig expression. Evaluate a trig expression. When this occurs, you're going to be given some weird value. Something you're not going to be able to figure out. Which means you have to figure out, is it a sum or is it a difference formula? And if so, which trig function? Sine, cosine, or tangent?
Difference.
Remember, cosine, if it was a sum of cosines, it could be a subtraction in between. So what we have to do is look at the patterns of the sines and cosines as to what goes where. So I know it's not a tangent one. Everybody okay with that?
Yes.
So if I'm looking at my sheet here, it goes, since it goes sine, cosine, and then cosine, sine, that means it has to be a sine of x and y. But what's going to go between the two? It's going to be subtraction, because since this is subtraction here, if I look on my sheet, it's got to be subtraction here, which means this is the sine of 42 minus 12, which is the sine of 30, which is? Right. You're just looking at this to decide which one you're using. You're working backwards off of that.
That's the end.
Yeah, it's quite literally that fast.
The other side.
You didn't need to. Because this is your x, y, x, y. Because when you're trying to figure it out here is by looking at this sheet. The sheet will tell you. So I've got sine, cosine, cosine, sine, sine, cosine, cosine, sine. Oh, that's a sine, either a sum or a difference. Then I look at the sign in the middle. Since it's subtraction, then it's a subtraction. So it's a difference of signs.
So if they're both the same.
If it's cosine, cosine, sine, sine, that means it had a difference or sum of cosines.
Well, like.
Let me show you another example. It goes sine, cosine, cosine, sine. Which one of those patterns goes sine, cosine, cosine, sine on my sheet? Which one? Sum of sines. So it's going to be a sine. What's the sine of 180? I meant to write down.
One of them should be 30 or.
Oh, it's a typo. Yeah, it's a typo. So it should be the sine. Yeah, it just wrote it out. It's not solved for it. Not the exact. It's just, yeah, this is just write out the example. So this would be the sine of 190. I looked at the wrong problem, but if I wanted to solve the exact one, it'll be one that works. So one that would be exact would be like this. If I look at that one, if it goes cosine 15, cosine sine, or cosine 50, cosine 60, the next one's sine 15, sine 60. On here, which one has cosine, cosine, sine, sine? It's going to be a cosines problem. And since that portion is an addition, means it's got to be a difference. So this is going to be the cosine of 15 minus 60. So it's just negative 45. Okay. You're just bouncing off the pattern that's given to you. Right? Right? You're bouncing off the pattern and see what the two is. You know, I'm going to give you the extra day to do the work because there's only one set of assignments, but we're going to get through all the different examples that we need. It's just going to, yeah, we're going to do the homework check, make sure we all, because it's just different. You know, it might take, I'm anticipating it just takes an extra minute. So with these things, you can do that, some very simple proof, that they kind of like that simplify verify stuff, but you're using the sum and difference formulas to show how they work. Okay? So we do an example of this. This is like a verify problem that we did earlier.
Oh, good.
So we're going to verify the identity cosine of pi over 2 minus x equals sine of x. And the way that we do this is that we're going to use cosine difference setup. So I'm going to write it out in terms of cosine of x minus y. And I use my sheet. I use the sheet. Cosine, well, that's going to be cosine of pi over 2 times the cosine of x. Since the difference will be plus then the sine pi over 2 and the sine of x. Sir?
Well, in that identity, that just says that that's equal to sine of x.
Mm-hmm. You're proving that. It's that verify. And you verify it using this difference formula. So what's the cosine of pi over 2? Pi over 2 is vertical, so what's cosine at 90? 0. What's 0 times the cosine of x? 0. What's 0 times anything?
0.
Okay. What's the sine of pi over 2? 1. What's 1 times the sine of x? What's 0 plus the sine of x? Done.
How do you do that?
Fancy.
Just by using those difference formulas in sum formulas, it's the sheet's right there. It goes back to the idea: can you set up and do the sines of the normal angles, the trig functions of the normal angles? You can do that. You'll be all right.
What are we doing tomorrow?
A little bit more of this. So take a minute, simplify these two, please. So it's cosine difference. So you fill in the blanks with the cosine difference formula. So it's cosine theta cosine 3 pi over 2. It's difference, so that means the next part will be plus sine theta sine 3 pi 2. Cosine of theta is cosine of theta. What's the cosine at 3 pi over 2? 0. So this side is 0. Well, what's 0 times cosine theta? Cosine of 3 pi over 2 is 0.
Oh, I did put that, but
I'm 0.
What's the sine of 3 pi over 2?
Negative 1.
Negative 1. So you get negative 1 times the sine of theta, which gives you negative sine theta.
wait, just real quick. Okay, so I accidentally put like the cosine as -1 and the sine is 0, so if I did that on the test, then I'm not right against it.
No, because if cosine is negative, then you would have negative cosine.
I still got negative.
And then the last one with the tangent, we haven't done one yet, might as well do that real quick. So you have to figure out what the tangent of 3 pi is. Remember, 0, 1, 2, 3. It is. Tangent at 3 pi is 0. So this becomes tangent theta plus 0 over 1 minus. Well, what's tangent theta times 0?
0.
0.
So negative.
So what's 1 minus 0? And what's tangent theta divided by 1?
I guess tangent.
Okay. I'm not lying, guys. It's just a matter of following through on the sheets here, okay? Try and get as much of them through today. We'll go a bunch of them tomorrow again and see how we do.
Sounds good.
All right.
You don't have to.
Why does he
I'll
always
write
have
it
to
on
do
the
it?
board over here. On the board over here.
You would think, right?
Well, I need to write it right here. Who wrote that?
Geometry. I want to.
It's like that geometry.
Oh, man.
You all caught up? Thanks, sir.